Hello everyone. Have you ever imagined drifting alone in the endless darkness of space? And then, in front of you, a perfect black void, wrapped in a strange glowing ring. This is no ordinary darkness. It's a supermassive black hole, a cosmic monster at the heart of our galaxy. And you are falling straight into it. What happens next will change everything you think you know about the universe. The question is, how much time will you have before everything disappears? This monster has a name, Sagittarius A. It sits 26,000 light-years from Earth, hidden in the dense star fields of the Milky Way's center. According to NASA's Chandra X-ray Observatory and the Event Horizon Telescope, Sagittarius A has a mass about 4 million times that of the Sunday. Its event horizon, the invisible point of no return, is 11.8 million kilometers from its center. That's nearly 930 times the diameter of Earth. And right now, in our thought experiment, you are heading straight for it. From far away, everything seems calm. The stars shine as they always do. But as you approach, the view begins to distort. Light from stars behind the black hole bends and twists around it, forming a glowing halo. This phenomenon is called gravitational lensing, predicted by Einstein's general theory of relativity in 1915 and observed countless times since. Your speed increases rapidly, accelerating toward the cosmic speed limit, nearly 300,000 kilometers per second. Ahead of you lies the event horizon, an invisible spherical boundary at that 11.8 million kilometer mark. Outside it, escape is theoretically possible if you had a rocket of unimaginable power. Inside it, every possible path through spacetime leads inward. Even light, the fastest thing in the universe, cannot get out. Cross this threshold and your fate is sealed. From your perspective, time flows normally. Your watch ticks second by second. But to an outside observer, something strange happens. They would see you slow down, your image fading and turning redder and redder as the light you emit is stretched to longer wavelengths. Eventually, you would appear frozen at the edge, never quite crossing, fading into invisibility. This is gravitational time dilation, one of the most mind-bending predictions of relativity, confirmed by experiments with satellites, atomic clocks, and even the GPS system we use every day. Inside the horizon, your course is fixed. You can't turn around, and you can't stop falling. The entire outside universe is now compressed into a small, bright circle of light behind you. Ahead is pure blackness, the singularity, a point where density becomes infinite and our current laws of physics break down entirely. Here's the second surprise. From the event horizon to the singularity of Sagittarius A, the journey lasts about 62 seconds according to your own clock. That's because the radius of the horizon is 11.8 million kilometers, and the free-fall time from that point is fixed by the geometry of space-time itself. For the first few seconds, you might still see that strange circle of light behind you, warped, flickering, changing colors as the light from distant stars is bent and twisted in extreme ways. But as you fall deeper, tidal forces grow rapidly. Near the singularity, the difference in gravitational pull between your head and feet climbs to millions of times stronger than Earth's gravity. No material can withstand it. You're stretched lengthwise and squeezed sideways in a process nicknamed spaghettification by physicist John Wheeler. Your atoms are torn apart, reduced to a stream of subatomic particles racing into the singularity. What happens at the singularity? We don't know. Some theories, like Stephen Hawking's part, suggest that information about everything that fell in is lost forever. Others believe the information is somehow stored at the horizon in quantum form, soft hair as some call it. And a few speculative ideas imagine that the singularity is actually a doorway to another universe, connected by a wormhole. But no one has ever returned from beyond an event horizon to tell us. Now imagine if this weren't a supermassive black hole, but a stellar mass one, maybe 10 times the mass of the Sunday. In that case, tidal forces near the horizon would be so strong that you'd be torn apart thousands of kilometers before even reaching it. Your journey would last less than 1,000th of a second from horizon to singularity, far too fast to even process what's happening. But here, in a giant like Sagittarius A, you've had a whole minute. A minute to witness the most alien, mind-bending view in the cosmos. A minute to reflect on the vastness of the universe and your tiny place within it. 62 seconds. That's all you get after crossing the event horizon of Sagittarius A. If you die, you won't have time to feel it. If you survive, you won't notice the moment everything changes. And in the end, you will disappear into eternal darkness. Of course, everything you've just seen is a thought experiment. Because even today, scientists are still debating whether black holes truly exist or if they're just one of the universe's greatest illusions. See you in the next video, and make sure to follow and subscribe to my channel.